Hello class, today we're going to be on to 1.4 and we're going to be talking about domain of invertibility and rate of change in y-intercepts of inverses. So when you see this RoC, big R, little o, big C, that stands for rate of change, and rate of change is just another word for slope, really, when we're working with a linear function. So when you see rate of change, just think slope. How is it changing over time? So let's first talk about the domain of invertibility. That's what all of this will be about. And we're going to define domain in a much more spectacular way later. But let's just kind of review it. And I want to right now think of the domain in terms of this. What x values can I plug in so that the function still works, right? Sometimes, like for instance, if we have something where we plug in a 0 and 0 is on the bottom, we can't divide by 0, so that's not part of the domain. Or also, if you recall, we can't have negative numbers under a square root. So we need to remember that we can't have a negative number under a square root. So if we have the square root where it's the square root of x must be greater than or equal to 0. Because if I plug in, say, a number greater than 0, 3, well, square root of 3, that's okay. I could plug in 0, it's or equal to. Square root of 0 is just 0, that's fine. But I can't plug in like a negative 4 and call it a day, right? Because that gets into imaginary numbers, which we'll get into later. But for now, let's just remember that we can't have a negative under the square root, because that's what we'll be working with, square functions. So let's review the steps. The first step is we need to find f inverse of x. So we should be getting okay at that by now. We've been working with inverses. In fact, this one is no different than what we did yesterday. And then once we find the inverse, I'll give you a little hint. We will actually have a square root in the inverse. And step 2 is determine which x values give us 0 under the radical, or the square root. Radical is just another word for the square root sign. It's kind of like the more official word. So I'll be using square root sign or radical interchangeably. And so once we finally figure out what x value gives us 0 under the radical, we want to determine which direction gives us positive values under the radical. Because from the number that gives us 0, if we go one way, it'll give us positive values. If we go the other way, it gives us negative values. And then we'll want to write that appropriate interval to something that looks like this. Okay, x is greater than or less than or equal to some number. Okay, so let's start off with this example right here. F of x is equal to x minus 4 squared minus 3. So step 1, let's find the inverse of this function. So remember the steps, and if you have to, just go back in your notebook and look at the steps that we do in order to find the inverse. In this case, turn f of x into y. So y equals x minus 4 squared minus 3. And then we want to switch our variables. So y becomes x and x becomes y. So x equals y minus y minus 4 squared minus 3. And now we want to solve for our new y. So remember, we need to get whatever is being squared by itself in these cases. So we're going to add 3 to both sides. Which is going to give us x plus 3 is equal to y minus 4 squared. And then now that we have the square by itself, let's undo the square by taking the square root. And what we do to one side, remember, we have to do the other side. So that square root cancels out that square. So on the right side, we just have y minus 4. And on the left side, remember, we're going to have a plus or minus here because we took the square root of something. The square root of x plus 3. And then get y by itself, add 4. So, and I'm going to throw the 4 up front. Remember, it doesn't matter if you put it in front or behind, or in front or after the square root of x plus 3. I'm going to have 4 plus or minus the square root of x plus 3 equals y. And then just for show, I will put the f inverse in there. So f inverse equals 4 plus or minus the square root of x plus 3. So we found f inverse, so that's step 1. I know it's a rather long step, but it's not a new step for us, so that's good at least. Now, this is the new step. I want to determine which x values can I plug in so that this function still exists. And I'll give you a hint. When it doesn't exist is when we'll have a negative under the square root. So we need to determine which x values gives us, or which x value gives us 0 under the radical. So I want to focus just on the radical portion right here. The rest of it I don't care about right now. And I just want to focus on that. There are 2 ways to do this. One, you can just kind of look at it. Sometimes the numbers will be nice enough where we're like, oh, well, I know if I plug in -3 here, I'll get 0, right? Because -3 plus 3 is equal to 0. If it's a little more complicated, or if you prefer, you can set what's under the square root equal to 0 and solve for x. So I'll show you how that looks. You can say, okay, x plus 3, I want to know when that is going to equal 0. So you just subtract 3 from both sides, and you'll see x is equal to -3. So -3 here is our number that's important to us. This is the very edge of a number that we can plug in to have it still exist. Now, x is related to -3 somehow, but I don't know if I need to put a greater than or equal to sign here or a less than or equal to sign here. So let's think about the direction. Let's first pick a number that's greater than -3. So recall in the number line, a number that's greater than -3 will be closer to 0. So let's plug in -2 and see if that works. So I plug in -2 in for x, and we're going to have, let's see, -2 plus 3. And this is just my scratch work off to the side. -2 plus 3 is going to equal to the square root of 1. So we know that positive, or we know as we get larger numbers, more positive, we're going to get a positive number under the radical. So x must be greater than or equal to -3. Look what happens if I plug a number that's less than -3. Let's say -4. -4 plus 3, well, -4 plus 3 is equal to -1. We'll have a negative under the square root, under the radical. Can't do that. So that's why x is going to be greater than or equal to -3. And why is it or equal to? If I plug in -3, I get 0, right? And that's okay. Having a 0 under a square root is okay. So let's go over another example here. What color should I use? I'll use green. Because why not, right? Okay. And this example, let's say that we have g of x is equal to 3 times x plus 2 squared plus 1. So let's find the inverse. Let's see, we're going to turn g of x to y. Switch our variables. And then we're going to solve for our new y. So let's get what's being squared by itself before we take the square root here. So we're going to subtract 1 from both sides. Good. Flying pens. Okay, x minus 1 equals 3 times y plus 2 squared. But unlike our example over here, after we move this number over, here we still have a 3 that's being multiplied. So let's go ahead and divide both sides by 3, because the 3 isn't being squared. Only what's in the parentheses is being squared. So that will cancel this out. So we're going to have x minus 1 over 3 equals y plus 2 squared. And then now we can take the square root. Let's see. Okay. So the square root cancels out the square. And let's see, sorry, brain explosion. Okay, so we're going to have x, the square root of x minus 1 over 3 equals y plus 2. And then finally subtract 2 from both sides. Oh, I forgot my plus or minus here. So, once we subtract the 2 over, we're going to have negative 2 plus or minus square root of x minus 1 over 3 is equal to y. And then I can just move my y over to the left, or switch these, right, and write f inverse of x equals negative 2 plus or minus square root of x minus 1 over 3. So let's remember that all I'm concerned about is with this radical here. Nothing else will matter here for us. So let's see, what number can I plug in so that I get 0 under the square root here? I can plug in, it looks like I could plug in 4. And let's just verify that using some algebra here. So I'm going to set this equal to 0. Do my scratch work off to the side. So I'm going to just x minus 1 over 3 equals 0. Let's multiply both sides by 3. This will cancel. So x minus 1 equals 0. And then, plus 1. I don't know what I was thinking with 4. Of course, it's 1, right? I could plug in 1 and I get 0. I was thinking of a 3 there. But if I plug in 1, 1 minus 1 equals 0. 0 over 3 is 0. So I can plug in 1. That will give me 0 under the square root. So let's see here. What direction are we going now? Because I know that x is going to be something to 1, whether it's greater than or less than. And you might see a pattern here after we do this one. If I plug in a number greater than 1, let's plug in 2. 2 minus 1 is 1. 1 over 3 is positive. So I can plug in a 2. What if I plug in a number less than 1, such as 0? 0 minus 1 is negative 1. So that would be negative 1/3. I can't have that because that's a negative. So it looks like I need to plug in numbers greater than 1. So x is going to be greater than or equal to 1. So that is how we find the domain of invertibility. Trying to think if we should go on to the next one, because this was a lot of information I threw at you. Let's go ahead and talk about the rate of change in y-intercept really quick. I think you guys can handle it. So rate of change in y-intercepts of inverses. So this is something slightly different. This is kind of a different idea that we're doing. And let's recall that f of x equals mx plus b, because we're working with linear functions here. Remember, that's the general form of a linear function, where m is our slope, or rate of change, remember, and b is our y-intercept. So this one is really easy. This is why I kind of decided just to tack this on at the end, and this one I think we can do it. So to find the inverse's rate of, because what we want to do is we want to find the rate of change in the y-intercept of the inverse of a function. So in order to find the inverse's rate of change and its y-intercept, we need to find the inverse and determine its m and b values. This one really not that bad. So let's go ahead and find the inverse of f of x, and I will use blue. Why not? Okay, so first change f of x to y. Y equals 3x minus 2 over 5, and then change our variables. So x is equal to 3y minus 2 over 5. And then now let's solve for our new y. So we can't add 2 over yet because it's being divided by 5. The first thing we want to do is generally, let's get rid of fractions. We don't like working with fractions, so let's get rid of that fraction. So what I want to do is we're being divided by 5, so let's multiply both sides by 5, which will cancel this out, which was the point. And now we're going to have 5x is equal to 3y minus 2. And now we can move this 2 over because nothing is happening to that 2. So let's add 2 to both sides. Remember, we can't combine x values and not x values, so we're going to have 5x plus 2 equals 3y. Now y is almost by itself. We're not there just yet. We want to go ahead and divide both sides by 3 because it's the opposite operation. And I'm dividing the whole thing by 3. And notice that we can't simplify this. 5 doesn't go into, or 3 doesn't go into 5, 3 doesn't go into 2. Even if it did, I guess you could simplify. But we're just going to leave it written just like that with a fraction. So y is equal to 5x plus 2 over 3. Or I could write it as f inverse of x is equal to 5x plus 2 over 3. Well, now that we have the inverse, we just need to determine its m value and its y value. M value and b value. Well, look at this. This might not look like y equals mx plus b, but it really is. Say if we have, let's see if I have something. A little sticky note. Say if I were to cover this up, doesn't this now look like y equals mx plus b? Yeah, it does. But we have this 3 down here. So all we need to do is think of it like this. Five over 3 is our m value. And 2 over 3 is our b value. So our m is 5 over 3, and our b is 2 over 3. And that's that. This is the rate of change of f inverse, and this is the rate of this is the, what am I saying? This is the y-intercept of f inverse. That's all we got to do. Let's go over one more example just to kind of get this ingrained in our brain. Let's say that we now have something like, I don't know what color I'm using. It's always a hard decision. Okay, I'll just use this. Let's say we have g of x is equal to 4x plus 1 over 2. Okay. So let's see here. Find the inverse. So y equals 4x plus 1 over 2, switch the variables, x equals 4y plus 1 over 2, and then solve. So again, we need to get rid of this fraction right away. So let's multiply both sides by 2. Since we're dividing both sides by 2, that will cancel. So we're going to have 2x is equal to 4y plus 1. Then now we can move this 1 over, so subtract 1 from both sides. So we're going to have 2x minus 1 equals 4y. And then divide both sides by 4. So that will cancel. Will give us y equals, remember we're just going to leave it just like this. 2x minus 1 over 4. No need to make life harder on ourselves. And then I'm going to put g inverse back in there. Awesome. So now we can just determine what our m is and what our b is. M is going to be 2 over 4. And then our b is going to be negative 1 over 4. Why negative? Because it's a minus 1 there. So the, g, I keep goofing, g inverse of m is 2 over 4. You can reduce that to 1/2 if you'd like. You don't need to. And then we have g inverse of x, our b, is negative 1 over 4. And that's it. So that's our lesson for today. Let me know if you all have any questions, and have a good day.